All right, well, it's springtime here. I can hear the birds outside my window, but we're gonna go back to wintertime and talk about object-oriented programming and build this really nice kind of meditative snowfall simulator in processing. What you're seeing over here is generated completely with code using processing. And again, this is gonna be a longer video. We're going to start by just doing a quick refresher on object-oriented programming to create these snowflakes, and then we're going to add a whole bunch of stuff to this. So if you're just kind of wanting to check out the super simple basics of object-oriented programming, I'd recommend looking in the processing examples or under Creative Programming 1, the GitHub. I'll put the link down below. You can see some examples of doing object-oriented programming with processing. They're a little bit simpler. So this is going to assume that you've kind of done it before. This is kind of a quick refresh as we get back into doing that and seeing the power of using object-oriented programming for something like this, where we can have hundreds or thousands of objects on the screen being affected by things like wind and stuff like that. So this is our example running. But let's start by, a project like this, it's so hard. I mean, like, you could watch a bunch of YouTube videos of snow and be completely overwhelmed by all the options. Then you do some research and you're thinking, oh man, like this is so many like elements to keep track of, or how do you even start? So I think breaking it down, being really simple is a really good place to start. So what we're going to do is we're going to create a single snowflake, then we're going to make it move, and then we're going to create a bunch of them and then add behavior to it from there. So before we do anything else, actually, let's go ahead and create our sketch like this. I'm also going to turn off the cursor because we don't want that blocking our beautiful snowfall. And then in our draw, now unusually for me at least, I'm going to use some color here. Not very much color, but a little color. Let's do this kind of nice blue, dark blue color. One really great way of kind of manipulating or changing color overall in processing actually is to kind of like reduce the red and increase the blue, or vice versa. You could even have a variable to do that. So you can here you can see the green is at 40, and then the red is 10 lower and the blue is 10 higher, which works really great. You could also create a variable called warm, for example, and then this could be 40 minus warm, and this could be 40 plus warm, and you could do that across all of your colors in your sketch, and that would let you have this kind of global parameter that controls the warmth or coolness of colors. For now, we'll do it by hand. So there's our sky, and already it's like, oh man, there's all these things we could add or change. We could make it have a gradient that looks really nice. You could have sunrise and sunset and all, okay, so we're getting ahead of ourselves. We're gonna keep this simple for now. And the next thing that we need to do is create a class for our snowflakes, a way of kind of like organizing and separating the sort of like template for a snowflake from its actual existence in our code. So I'm going to create a class called flake, and there's a couple of things that we need for a basic class. We need our constructor, which is how an instance or a specific example of our class gets actually created in our code. And that's always, so you also notice classes in Java are capitalized, and other things like variables and functions are lowercase. So one thing you might notice is something like p vector is capitalized, or string, and that's because those are actually classes. They're more complicated kind of under the hood. But our constructor is the same as the name of our class, and then in parentheses are any arguments that we pass in when we create that. And for now, we're going to leave that blank. And then also in our class, we have methods. And methods are functions that let us do things like display our snowflake on the screen. We can create as many methods as we want. We can call them anything we want. Though generally in this case, I'm not going to call this draw, because draw, you'll see it changes color. Draw is reserved up here for our main draw loop. So you'll see really commonly in processing examples, display is used, and I think that kind of makes sense. And then the other thing that our class is going to have is some kind of variables associated with it. And these are basic variables that apply to the whole class, and then we can change the values for each instance of that class. So each snowflake, for example, should probably have a position. And so we can create a variable here, and then when it's created, we can give it a position. So to get started, let's create a single snowflake, and then we can kind of change this. So I'm going to say flake f, and then let's start f will be a new flake object. And I think it makes sense to pass in an x and a y position, at least for now. We may want to change this. So let's start it at width divided by 2, height divided by 2. And then our constructor here, we need to pass in float x, float y. And then we're going to say position equals new p vector x and y. We've got that. And then let's just go ahead. Right now it's going to be really simple, but we can add a way for us to see this. So we can do push matrix, pop matrix, translate pos.x, pos.y. And then let's just do fill kind of a semi-transparent white, and we can draw an ellipse at 0, 0 because we used translate. So now 0, 0 is our current position, 0, 0, and then for now let's just make it 100 by 100. We'll change that in a sec because we want to know its diameter. Oh, and so we don't see it because we actually aren't drawing it on screen yet. So remember, your class is like a template that defines the generic structure of your class, but f in this case is our single flake instance of the flake class. So down in draw, we need to say f.display. And so there it is. There's our little snowflake. It's not a snowflake yet, but that looks pretty good. And I think this is another good example where we want to start piece by piece, run our code, make sure everything works, and then keep adding to it and changing it. Cool. So I think the first thing to do now that we've got this kind of basic structure working is, a snowflake is not a circle, but it has like the kind of points, or it's like a little star. So let's create some variables that will define our snowflake. And we could, let's start by just hard coding. Hard coding means that we type in the values directly into our code. We'll start with that, and then in a little bit we'll change it so that there's a range and each snowflake picks kind of randomly from that. So I'm going to say integer num points equals, let's do, 9 for now. We can try changing that. We're also going to need an inner radius and an outer radius for drawing our circle. So I'm going to say my inner radius, let's see, inner radius, and we'll set that equal to maybe 24, something big enough that we can see. Float outer radius equals, and in this case, I actually think rather than defining those two numbers, we could do that kind of directly, but I think actually what might make more sense is to, actually, let's make this the outer radius. We can make our inner radius a ratio of the outer radius. That way we don't have to define them separately. So I can say this inner radius is the outer radius divided by 1.5. So it'll be slightly smaller. So that's good. So now we have a number of points for our star. We've got the radius, both those radii that we need. Just thinking if we need anything else yet. I don't think so. So then down here in our constructor, we don't need anything else. In a little bit, when we randomize this stuff, we'll do that when it's instantiated, when we create it using the constructor. And then in our display here, so push matrix is going to stay the same. Our fill and stroke can stay the same. But now we need to, instead of drawing an ellipse, we need to draw this star. And there's a lot of ways that we could do this. We might even want to make a separate function for this. But I think for now we can just kind of do it here. I think that makes sense. So the first thing that we want to know is we have a certain number of points, and we need to know what the angle is between those points as we draw on the circle. So I'm going to make a float called angle, and that's going to be the full circle, or 2 pi, remember we're in radians for everything, divided by the num points. So that's going to be our angle between them, and then we can use begin shape and end shape. And I'm going to put close in there right now so I don't forget that connects the last point and the first point. And then what we need to do is go around the circle and draw all of our points. And this is the way you would draw a complex polygon. So I can say for float a equals 0, a is less than full circle. Oops, I, force of habit. A is less than 2 pi, a plus equals our angle. So now we're going to start up here, and then we're going to move over by that angle, draw a vertex, draw over by that angle until we go around the full circle. Now, you might think, oh, this is a great place to use translate and rotate to be able to do this, but I'm not actually sure why, but you can't use those inside begin and end shape. It's too bad. So instead, we have to rely on, I'm sorry to say, a little trigonometry to get our x and our y position, but it's actually not that scary. So x is equal to the cosine of the angle times the outer radius, and y is equal to the sine of the angle times the outer radius. So this converts an angle and a distance into an x and a y position, and this these two formulas are really, really helpful. They're all relative to 0, 0. So we're using translate here, which means we don't need anything else. If we did want it to be in a different location, then we would need it to look something like this. So we add the position to it. But because we're using translate, and this is why translate's really great, we don't have to mess around with any relative coordinates. We're all off of 0, 0. And then we can say vertex, x and y. And now this won't draw a star. This will draw a 9-pointed shape, but you can see here it's working. That looks really good. Now to draw the points, so the inner parts, we can actually, so we draw the vertex at the outer radius, and now we're going to say x is equal to the cosine of a plus angle divided by 2. So halfway between the current point and the next one times inner radius, and the same thing for y. And then a vertex at x and y. And now we can see, now I'm going to make this a little bigger. For now, 24 is kind of too small, so let's make it a little bigger. There we go. So now we can see the star shape, and if I change the number of points from 9 to 12, we get 12-pointed, 5. We could even do a 100-pointed star if we want. We get something that looks like this. You could also change this ratio of the inner radius to the outer radius to be, you know, the larger this number is, the bigger the distance. So right now it's divided by 2, or you could divide it by, you know, 0.8, 1.8. You get this, 1.1, give you something like that. So that may vary, and you might also want to change this randomly for each one so that they would be like more bulbous or more pointy. For now, I'm just going to leave that at 1.5 because I think that looks pretty good. So we've got our snowflake. This is pretty fun. Let's try randomizing this now. You know, we want, they say every snowflake is unique. There's probably some debate on whether that's actually true. We should have done that research before we started this video. But the first thing actually I'm going to do is make a new tab for my class. You can already see my class is getting pretty hefty. So I'm going to go up here to this little guy here, click on new tab. I'm going to call this flake and just paste this in. So now I've got my class on a different tab. I should probably save this as well and save this to the desktop. Okay. So I'm calling it Snowfall, and then I've got this tab called Flake that has my Flake class. And this is a really good example actually of what your sketch ideally should look like, which is that your setup and your draw are really simple, and most of the work is happening somewhere else in functions or in classes. I think a good way to think about your draw is it's almost like a script. It's saying in a very generic way, do this, then do this, then do this, then do this. And the real work of that is happening elsewhere in your sketch. It makes it much easier to kind of prototype and modify and understand what's going on. So nothing should have changed in how it works. We're just sort of moving this over. Now let's say we want to make these more randomized. So first thing I want to do is change the number of points. So I can say the min points is maybe equal to 5. Otherwise, 4 is a square. Max points is equal to 12. You could play with this how you want. And so then min points becomes, I like to kind of organize variables that I change up near the top and ones that I don't at the bottom. So now num points is going to be equal to, remember it needs to be an integer. You can't have a floating point number of points around it. Random between 5 and 12. And so now actually again, we can just run this and see. That looks cool. Let's go ahead and put a sort of a reset button. So now when I press the key, we'll get a new number of points in the star. It's pretty cool. Okay, so we've got the number of points. Let's also change the radius. So we can say float min radius is 4. Float max radius is 12. These are numbers I just played around with before. And so then float outer radius and inner radius. And we're going to set these down here. So we can say outer radius is random between min radius and max radius. And then the inner radius is always still going to be relative to the outer one. So now when this runs, now it's really teeny. Let's just make this a little bigger so we can see it. So now every time I run this, it's going to be a random number of points and a random size, which is pretty cool. So we've got that. Great. This is all awesome. Sort of a generic Snowflake generator. You could, I'm sure, think of many ways of making this look cooler. You could add little dots on the tips or randomly choose to do that. You could add little lines coming out. You could cut a hole in the middle. You could do all kinds of really great things, I'm sure. Please make an awesome like random snow generator. I would love to see that. That'd be really great. Send me pictures. But it's not that exciting if it's not moving. So we've got our position vector, p vector here. Let's also create a p vector called speed. And speed is going to be how quickly this thing moves down. And later when we add wind, it'll also be how much it moves over. And we're going to initiate that in the constructor here as well. So I'm going to say, let's randomize this too while we're at it. We can say float down speed is equal to, actually, you know what? Let's not randomize it. Let's just make it set for now, and we can, yeah, we'll see. We're going to add some cool stuff to that later. So speed is a new p vector. There's no left to right speed for now. We'll add that in a little bit. And let's do, try to think what a good number would be. Let's try just 1 for now and see how that looks. So now we have this display method, which is great, but we probably want to separate the movement stuff from the drawing stuff. And again, this is where having a class is really nice, is it keeps it simple. We can make a template, and then our draw loop here isn't full of a ton of extra code. So every frame I want to do f.update and then f.display. And update is where I'm going to change that position. And so in a really simple way, I can just say pos.add speed. Super easy. And now we'll see as this runs, it's slowly falling. Keeps going. And eventually it'll go past the bottom, and that's something we're going to need to fix in a little bit. So this is cool. Maybe we want our position now, instead of being at our initial position being height divided by 2. Let's make it at 0, just so we can see it coming down. And let's go ahead and make this a little faster because we want to see that. So this is pretty great. We've got a snowflake. It's moving. Let's make a bunch of snowflakes. Like one snowflake is cool, but we want to see. Well, actually, let's do one more thing first, which I think will be good. When we imagine snowflakes falling, they're not sitting sort of straight like this, not moving at all. Let's make it rotate slowly while it's going around. So I think we're going to want to do a variable called, let's do that down here, float rotation speed. That's going to be how fast it's rotating. And then let's do rotation angle. So we need to keep track of how quickly it should change rotation and what its current position is in that rotation. So then we can, again, in our constructor, we can say that our rotation angle is going to be equal to 0. It's going to start at 0, though we could also actually well, in a minute we'll see. I think we want to randomize that. And our rotation speed could be equal to, well, let's do radians 2, and we'll see in a minute. We can also, randomize all this stuff. So our speed is going to be 2. Our angle is set to 0. And then in our update, we can also update that rotation angle. So rotation angle plus equals speed. And then here in our display, we can say rotate, and that happens after translate, rotation angle. And now we should see so this already feels so much more natural to me, where it's like rotating as it's falling. That looks really cool. And again, because I have a really solid class setup that's simple and kind of like well laid out, it makes it really easy for me to say, oh, I want to add rotation. Here are my global variables for that. Here's how I'm setting them. Here's how I'm updating them. And here's how I'm using them to draw. It makes it really easy to keep adding stuff, and it's not this spaghetti code in my draw. So great. We've made one snowflake. This seems good. Let's make a bunch. So for doing this, I'm going to use an array list, which, if you remember, an array list is like a regular array, except we can add and subtract elements really easily. And we want to put in these little characters the type of variable that it's holding. And in this case, it's holding our flake class. And we'll call this flakes. And then instead of making one new flake here, we can say flakes equals a new array list of the flake type. And then you need this little parentheses here. And then let's make a bunch. So I can say I equals 0, I is less than, let's make a global variable called numFlakes. We can make 100 for now. I is less than numFlakes. And then we can make a bunch of random ones. So we can say f equals new flake, and then we want its x position to be random between 0 and width, and its y position to be random. For now, we're going to do between 0 and height, and we'll change that in a bit. And then flakes.add our new snowflake. So now we're going through and we're going to create 100 random snowflakes. And then in our draw, we can use a for loop to display these. And for now, we can say we're going to use this, what's called an enhanced for loop, where we can say flake f in the list flakes. So the way you can kind of read this is for the flake named f in the list flakes, update it and display it. So I've created this array list. I'm creating 100 random snowflakes. Let's run this. They're really huge. So let's go back and shrink these down to a normal size. Pretty cool. So we're noticing, though, a couple of problems. One is that because they're all starting on the screen, then as they start to fall down, there's no new ones replacing them. And when they hit the bottom, they go off the screen, and basically they're still going. They're really far off the screen. So we want to change that. the first thing I think we want to do is make our snowflakes not between 0 and the height, but actually between above the screen and the top of the screen. And to do that, it would be between negative height and 0. So negative height is the full height above, and then all the way to the top. So now when we run this, we actually won't see any snowflakes right away, but now they start coming down, which looks really nice. So basically we've just offset that by the height of the screen. But we still have the problem that when they hit the bottom, they disappear, or they don't disappear, they sort of like are still there. So we can say if, so we want to know if they're off the screen, and we could make a function that would test this inside our class. I think it's fine to do it here. We can say if f.y plus, so we want to know not just is the center hit it, but f plus y, minus f.outer radius is greater than height, because we don't want to delete it before it's completely past the screen. So we can say this, and now we want to remove it from our list. And the only downside of this syntax here is that we don't have an index that we can use to remove it. To remove it from our list, we would say flakes.remove our index, and we don't have that. So instead what we need to do is say for int I equals 0, I is less than flakes.size. If you remember ArrayList, you don't have the dot length like a regular array, it's dot size. And then we need to get it from that ArrayList. So flake f equals flakes.get I. But now what's cool is we can delete it and we can make a new snowflake. So we can say, that's actually the same thing as here. Now we're going to get an error because we already have this variable here. So I'm just going to delete that. So f equals a new flake. Now I suppose it would also work to, instead of deleting it, to just change its position and restart it. But I like that it's going to completely redo it, where it's going to be a random, radius and all that stuff. And so it's saying cannot find f.y, and the reason is our position is defined by a p vector, so we need f.pos.y. And now we should see them falling, which looks really nice. And now we didn't have a print line here to tell us that they're being deleted and recreated, but we can see that they continue to fall, which looks nice. So I think everything is working correct. Yeah, yay, snow. So the next thing I think that I'd like to change is that they're all kind of at the same angle when they are created, and so they're all kind of falling at the same. The rotation is all kind of the same. So let's go ahead and change this initial angle to be a random value between 0 and 2 pi. This is maybe a subtle change. I mean, look, we're all subtle at this point. This is all about the little details that make this really feel natural. But I think if we have enough snowflakes, this will be a helpful thing. I can see too, I think there's some things that we could improve in terms of it initially generating the snowflakes. We're going to skip that for now. But this looks good. So before we make any more modifications to our snowflake class, and maybe you have ideas of things that could make this look a lot better, let's add another element. I would like to add a gusty wind that's blowing these around. And this is actually going to harken back to our first example that we did for this section on generating wind. We're going to use Perlin noise. If you haven't seen that video yet, go back and check it out. It explains how we use Perlin noise to make natural wind. And we could do that with variables inside of our regular sketch, but this is all about object-oriented programming. Let's go ahead and create a class called wind and a variable called wind. So I'm going to make another new tab and call it wind. I'm going to create my wind class. So I know here that I need a constructor. So I'm going to say wind. And in this case, there's going to be no arguments passed in because it's going to just be starting at 0. And what does my wind need? So my wind needs a force. And I'm going to set force equal to 0 to start. And then what else do I want? So I want an increment through this. So we're using Perl noise, so we need some kind of increment through that noise function. So float noise increment. We'll start that out as 0.1. We can see how that looks. And we need a noise offset. I'm going to start that at 0. That's going to be our value that we're going to change. So that looks good. Oh, and then, well, no, we'll come back to that. I think this is fine for now. So then we're going to need an update. And to do this, we're going to work through our Perl noise just like before. So I'm going to say noise offset plus equals noise increment. And then we need to get a value from the noise. So I'm going to say float noise value equals noise offset. So again, we're sending a number into the noise command, which gives us out the result. This is a one-dimensional, so it's giving us kind of this like back and forth gusting. And that's going to give us a number between 0 and 1. So now we want to convert it into something more usable. So I'm going to say noise value equals map noise value, which will be between 0 and 1. And I want to be able to change how much this is going to move over time. So I'm going to create another variable called speed increment. So noise increment is how quickly we're moving through the Perl noise. That's going to create either much smoother kinds of like gentle gusts or really rough gusts. Speed increment is going to change how much our snowflakes are actually able to move per frame. So I'm going to set that equal to 0.03. I want this to be really small. And so then this is going to be between 0 and 1, is converted to the range of negative speed increment and speed increment. Now, if we actually, let's just leave that. We'll see in a minute how this is not going to work super well for us. Oh, and you know what? Instead of doing a separate step, let's just say force.x plus equals this value. So our force, which is how much the wind is blowing, is going to be increased by this number every time. And we are going to see in a minute how this is not going to do quite what we want, but this is a good place to start. So then we want to go back to our main sketch, and we're going to create our wind object. So we're going to say wind equals new wind, and there's no arguments, nothing passed in, so that's easy. Then in our draw, this is our snowflakes. We also need to update the wind every frame. So that's going to change our position in the Perl noise and all that. So I can say wind.update, just like that. And update and display, those are not preset names. We can call them whatever we want. You can create all kinds of other functions if you want to inside your class. So now we need a way for the wind to affect our snowflakes. And I think the easiest thing to do would be, instead of our update just being on its own, we can send in the wind variable to it. So I'm going to say update, and now I go back to my flake class, and my update function now, instead of having no arguments, is going to have a wind variable called w, and I can call that whatever I want. And now I want to be able to change the position, not just on the speed, which is downward, but I want to change it to blow sideways. So I'm going to say pos.add w.force. So if you remember, every time this update in our wind class gets called, the force this way or this way of the wind gets changed, and then our flake class is going to take that into account. So now when I run this, we should see a little subtle, but we can see it's blowing sort of back and forth. We could change how intense that is, but you'll notice what's happening here, a couple of problems. One is eventually this could continue so that the wind is blowing sideways, and now all of our snowflakes are off the screen. So we might want to constrain how, like, the maximum force of the wind. So let's go ahead and do that. We can go back to our wind class. And now we can say, so right now it's being mapped between 0 and 1, and if the force is changing based on the increment, but I can say force.x is constrained. So this is a lot like what we did in that initial wind example. And then let's make a max wind speed, and we can constrain it to that. So now I can say float max speed equals, and again, I've been playing around with these numbers, so this feels good to me. 0.8 seems about right. And now we can see our wind should never get too out of control. And you could change that number to see, you know, kind of what feels right for the project that you're working on. But we'll notice that as it blows, you know, this area of the screen, oh, my cursor is gone, but the area of the screen on the right-hand side right now has no snowflakes, and that's because they start between 0 and the width of the screen. So I'm going to change one more thing here, and instead of our initial position being between 0 and the width, I'm going to make it between negative width and width times 2. So now snowflakes are going to spawn all the way over by 1 width of the screen, all the way past the screen, so that as the wind blows, we're not going to have a problem. Now we're probably going to want to increase our number of snowflakes, and this is why this is really the power of object-oriented programming, is that I can do that. I can just kind of like change this number, and now instead of having 100 snowflakes, I have 500 snowflakes all kind of blowing around, which is pretty cool. And let's see. Oops. Oh, so I changed it down here where this is getting created, but I didn't change it actually in my initial. So I want this to be negative width and width times 2. So, you know, I had to specify where these were going to go in the constructor. It might be that I want this actually to be defined inside my class here. This is where you kind of want to like tune those variables and think about what makes sense for you. But now, because of the flakes are being drawn all over the place, the wind isn't going to blow in such a way that we're going to have no snowflakes visible, or like a big chunk empty or something. So I'm pretty psyched about this. This looks cool. I think maybe we can change a couple more things. The first thing would be to have our snowflakes fall faster or slower depending on how big they are. They're all falling at this kind of same rate, which doesn't feel really natural to me. So let's create another set of variables. We're going to say min down speed. Let's make it 0.1, so really slow, and max could be 1.5. So it gives us a range. Again, you can play with this. And so now our speed here, instead of being preset, I can make a variable called down speed, and I can map this from the outer radius, which will be between, we know from our variables up here, our outer radius is between the min radius and the max radius. And we want the smallest ones to fall the fastest and the biggest ones to fall the slowest. So if it's between min radius and max radius, then we want our speed to be between the max and the minimum. Otherwise, our biggest ones would fall the fastest and the littlest would fall the smallest. And you might try that and think that that feels more natural to you. And so now our speed changed like that. And if we run this, we'll see, we should see, is that working right? Those all still seem to be the same to me. We should be seeing, maybe it's too little of a change. Let's try. Nope. So something is not quite right. I'm not sure why that's not working. Down speed. Boy, I'm not sure. Anyway, if you look in the example code, I promise you it's working right. I'll try to fix this and we'll come back if we can figure this out. But this way you could tie that speed to the size of your individual snowflake, which is pretty cool. One other thing, I'm just looking at my example here to see what else could we add. So let's just, I'm going to comment this out. We'll leave this for now. Well, no, we can leave it. That's fine. Let's add some wiggle. So right now they're also falling really linearly. But we think of snowflakes, especially like in cartoons, as having this kind of like back and forth wiggle. And this is kind of cool. We can use sign to do this. So I'm going to create another variable, float, called wiggle speed. Again, this is all things that we can control. And this is going to be really small because the sign goes between -1 and 1. So we don't want to go too quickly through that kind of range of things. And then the wiggle amount, or sorry, the wiggle angle is going to be kind of like our position. So again, you know, like thinking about the Perlin noise, we have a position within this noise, and as we change, we get new variables, new values. The same thing here, our angle that we feed into sign is going to give us a different result. If we start, well, let's start with 0 for all of them, and we'll see they're all going to kind of do it the same amount. So now our we can set our wiggle. That looks good. And now we can do this in our update. So here's our update method. We can say float wiggle equals the sign of our wiggle angle. These are some pretty weird variables. Wiggle angle times 0.5. That's a number I just picked that seems to work nicely. And then we can say pos.x plus equals that wiggle. So that's going to give us sort of like an offset back and forth. And then our angle is going to be plus equal the wiggle speed. So now when we run this, we'll see them. It's a little hard to see with the wind. Maybe we can turn off the wind. So now they're all doing this kind of wiggle. Maybe not so much that we can really see it. Let's try. There we go. So that doesn't look right, but you can see how it's like doing this back and forth. But they're all exactly the same, right? And that's because they all have the same wiggle angle. But instead, if you made this random between 0 and 2 pi, now each one is going to start in a different spot, and they all are going to have this kind of like randomized. Even though they're all wiggling at the same speed, they're all sort of randomized. And if we change this to be slower, that looks really nice. So right now there's no wind, but they have this really like organic kind of falling to them, which looks really cool. So the wiggle looks good. Maybe we can add our wind back in. Very good. So now we got this like random wiggle, plus they can be blown by the wind. And this is where everything starts to get subtle, and you can like add and tweak and change stuff to make some really cool results. Let's change one more thing, and then I think we're going to call it quits because this video is getting really long and we could do, honestly, hours and hours to this. Let's change the rotation speed based on how hard the wind is blowing. So if the wind is just a little bit, they're sort of like slowly rotating, and if the wind is blowing a lot, they're blowing really hard. And I'm going to do that again in my update here. So right now we're adding this rotation speed. Let's go ahead and say rotation speed equals map. So we have our wind object that we passed in as an argument, w.force.x, which is going to be between. Now this is cool. We want to know what's the maximum and minimum force that the wind might have, which is defined in our class here, our max speed. We can access that. So we could say w, or this, sorry, this would be negative w dot max speed and w dot max speed. So we can access those variables from that class directly. And we want to, let's just say between -3 and 3. And that's thinking in degrees, but we can do radians. We can convert it like this. So now the harder the wind is blowing, the faster it'll rotate. And if it's blowing to the left, it'll rotate to the left, and if it's blowing to the right, it'll rotate to the right because our resulting angles are negative or positive. So now our wind is blowing this way. We should see them all turning this direction. And if our wind changes direction, it'll blow the other way. And because it's Perlin noise, the change in that gust is not going to be as abrupt as it would be with the just like a random numbers. And so we should see these like nice kind of transitions back and forth. So our wind isn't really cooperating, but if you run this long enough, we'll see that that kind of changes. So yeah, that was a whole lot of stuff, but hopefully this gives you some ideas about how you can use object-oriented programming to structure something like this, where you want to define a generic template for something. You want to give it a bunch of parameters. Maybe some of those can be randomly defined within a certain range. They get created when that individual element gets kind of created. So when an individual snowflake gets created, it gets random values. We have some way of making changes and displaying it on the screen. And then it leaves our setup and our draw really, really simple so that we don't have to have this super complex thing. It becomes really easy kind of to tell what's going on here, but we can create these really complex behaviors. I'm sure you have lots of ideas for things that we can add to this. If you want to just grab the code and start messing with some of these settings or adding other things, I think that would be really cool. And I'd love to hear what ideas you have for sort of like making changes to this.